Now that I've given an overview of the LockManager app case study, it's time to turn our attention to the structure and functionality of the server side of the app. In particular, we're going to be talking about the LockManager Controller and the LockManager Service that are part of the LockManager application microservice. As usual, the LockManager Controller maps HTTP GET and POST requests to endpoint handler methods. As you can see, we have to annotate it with the REST controller annotation so it works properly to return the objects and serialize them into HTTP responses. And also, as usual, we auto-wire an instance of the LockManager Service using Spring's dependency injection framework. There's a number of methods that are defined here in this LockManager controller, including create, which is essentially a constructor, two versions of acquire, one of which gets back one lock, the other gives back a list of locks, and then there are two corresponding versions of release, one that releases a lock that was acquired earlier, and another that releases a list of locks that was acquired earlier. As you can see here, we use our conventional @post mapping and @get mapping annotations to instruct Spring to map incoming HTTP GET and POST requests to these particular endpoint handler methods. And also, again, no surprise, we define paths that are used to indicate what those methods will correspond to in terms of the path portions of an HTTP URL. And then we also have some annotations here where we're going to instruct Spring to take the incoming HTTP request body and map it to the corresponding Java object, such as an integer or a lock or a list of locks, as the case may be. And then there's also a couple of interesting return types. Most of the return types here are just Boolean, so I won't talk about them at this point. However, there are two other ones that are quite interesting, one of which is called deferred result, and it takes a lock, and the other is deferred result that takes a list of locks. Deferred result is a Spring class that's used to enable the computation in that method to run in the thread of its choice. It doesn't have to run in the servlet thread. Instead, it can run in a background thread, such as a virtual thread, as we're going to do in this particular implementation. And that provides some additional flexibility in terms of how you do the computations. Let's now turn our attention to the structure and functionality of the LockManager Service. So the LockManager Service defines some methods that are called by the LockManager Controller that are used to implement a distributed semaphore using Java Array Blocking Queue. We'll talk more about the Java Array Blocking Queue here in just a moment. As usual, we annotate this class using the @service annotation, which indicates to Spring that this class implements so-called business logic and ensures that auto-detection and wiring of dependent classes take place via class path scanning. We have a couple of fields here. The first field is an executor that's implemented using a new virtual thread per task executor that's used to run the incoming HTTP requests off the servlet thread and instead in a virtual thread. And you'll see this in a bit more detail when we talk about the implementation here in the next part of the lesson. And then there's also the use of an array blocking queue, which is a generic Java class that we parameterize with lock. And we use this to limit concurrent access to the fixed number of available locks that are managed by the LockManager service. And we'll take a look at this in more detail when we look at the implementation. But in a nutshell, array blocking queue is a very interesting synchronized data type that supports so-called bounded buffers. And in this case, what we're going to do is we're going to use it to implement our semaphore by defining a number of lock objects managed by the array blocking queue. And this will allow us to be able to do semaphore operations like acquiring and releasing either one semaphore at a time or groups of semaphores at a time, and to do it in a way that will be done atomically without having to know much about the internals of Java synchronization mechanisms like reentrant locks or synchronized methods, synchronized statements, and so on. We also, of course, have the methods that are used to actually implement all this stuff. These are the methods delegated by the LockManager Controller, and we'll see when we get to the next part of this lesson, this is where we actually implement the synchronous distributed semaphore semantics. So that's the end of the walkthrough of the LockManager server-side structure and functionality.